Sucking it, lick like a salad bowl. Let your Allen pole.
You guys have to pay attention. I don't know if you've watched this video before, but it's brilliant.
All right, let's see the triangles.
I think this is kind of a mad idea that you could measure the radius of the Earth.
Did you hear that? Trying to use the radius of the Earth using triangles. Just note that. Triangles, people.
Yeah.
With just a couple of triangles and a mountain and a bronze astrolabe. Okay, so let's say you've got the Earth like this.
Just going to draw a sphere. You don't really need to see how she draws a sphere. Okay, she puts a radius through to the center, and that is the mountain on the circled sphere. Remember, they've already assumed a sphere here.
Yep.
Now, if you draw yourself a nice right angle triangle here.
Creating a right triangle to the what? The horizon. Note that. Right triangle to the horizon.
So this is you looking at the horizon,
Exactly.
which is tangent to the surface of the Earth.
Looking at the horizon. So, Globers, would that be a physical horizon or a refracted horizon?
That would be a refracted horizon, Flats, because, you know, it's not no atmo day, like in your Black Swan straw man.
Note that I already didn't even know about refraction.
Viewer height in feet, 1,500. Refracted horizon dip, 0.635 degrees. Geometric horizon dip, 0.686 degrees. That's a difference of 0.051 degrees.
Exactly right. Then, you can make this right angle triangle.
They bring it to the center, obviously.
That was
Call it C.
C,
Yeah, you're looking at it.
but that's
Okay.
a right angle.
Yep.
So the difference will give us that little angle in there.
Yeah, or effectively gives you this angle
Oh
in
yeah,
there as
yeah,
well.
because that angle there, if that was
Call it C.
C,
Yeah, you're looking at
then
it.
that there is C.
Yeah, perfect.
You guys understand that? It's a depression angle, so C would be equivalent to C in the center. So they're just duplicating the angle so they can put it inside a sphere. Note.
Gotcha.
Now, this is
Duplication.
right angle triangle, right? So this distance here, can I have another pen?
Yeah, sure.
Okay, now she's just going to do globe math. We obviously don't need to do it. Weird how they're using costs and everything. Now the fun comes. Because this is what they actually do it with.
You want the height? You want to work out the height of the shard as well?
Yeah.
Okay,
And we're doing the whole thing.
Okay, fine. Right, so here's the shard then.
I grew a beard for this and everything.
And a very impressive one it is too. Okay, so here's the
Go
height.
old school.
Okay, so they're drawing the shard. That's the building in the back there. If you guys don't know, the shard.
This is the shard. This
Yep.
is the height that we need. H.
Yep.
We're
What's that? Is that a flat baseline? So they can work out the height of the shard?
close enough to the shard that the Earth can be flat.
Ah, to work it out, it has to be flat.
Close enough to the shard that the Earth can be flat.
Ah, to work it out, it has to be flat.
I'm speaking to you loud and clear.
You only hear what you want to hear.
What did you say? Let's rewind at the touch again.
So now,
Oh yeah.
Sorry, what did you say again?
we're close enough to the shard that the Earth can be flat.
So saying close enough to the shard that the Earth could be flat. You see, that's the way they do. They have to obfuscate from, they actually require a flat baseline to work it out. So, they have to change the words to say, we're close enough that the Earth could be flat. No, it's simply, it is flat, that's why you're measuring it flat, and afterwards, adapting it to your sphere.
Gotcha.
So now,
Oh yeah. I'm happy to assume that.
the way that you can do it
I put tracking down.
is from a reasonable distance away, say here,
Yep.
we can look up
Gotcha.
at the shard, measure that angle.
Hey.
Cool. So, measuring angle A to the top of the mountain, in Alberini's case, yeah, it would be the shard. Angle A. That would be a right angle triangle. Let's carry on.
I'm going all over the place with
Yeah.
the letters here. And then we'll go a little bit further away, and we'll measure it again. B.
And that would be angle B, because they're walking. So in other words, they take the first angle there and they walk away and make the second angle based on the same horizontal plane. Everybody? On a globe, you've got a bit of an issue there because that zenith would be a different zenith to that. So it wouldn't have the same 90-degree angle to the shard. So what does that tell you? Flat baseline.
And then as long as we know this distance here, maybe we'll do like 100 meters or so.
Yep.
Let's call that D.
30 for distance. Yep.
Then you can use
Okay, so that's just what they did actually. They took the measurement there at A, using his Kamal or whatever he used, and then he paced distances to B, let's say 100 yards or feet or whatever, and he took another angular distance. That's how he can work out. Because they know that physical distance between point A, point B, then they can work out the trigonometric function to get that height.
So if you use a small part of a sphere, you can presume it's flat, as shown when you zoom in. It looks pretty flat. It is pretty flat over a small amount of distance. So yeah, you can assume it's flat for so long, until you have to start taking the curve into account. So Flatzoid, you said because it's measured flat, you can measure the height, and you wouldn't be able to do that on a globe. Tell me, why can't you measure the height of the sun or Polaris, etc.? Thanks for admitting that the Earth is a globe. You inadvertently admitted that the Earth is a globe. Thank you for the globe evidence, Flats. Because the angles to the sun and the angles to Polaris do not match a flat Earth, do they? No, they match a sphere. They match a globe. That's why when you try to get the height of Polaris or the sun, etc., you end up with multiple different heights for them, because the Earth is not flat. So thanks for that evidence, Flats, and showing why it's a globe and not flat.
What did I tell you guys? You guys have to pay attention. I don't know if you've watched this video before, but it's brilliant.
Let's tell the world why you don't like me. Look what you're into, you doubted me highly. I rated you, yeah, let me not front. I didn't take shots, you're insecure. Now I hope you're a bulletproof monk. I have to rub my jaw. You tried to draw man out, are you sure? I wanna be rich, fuck you and you're poor. Don't take shots if you can't score. You got my number and you tweeted me. Where I'm from, that's sneaky G. Don't run your mouth in the net, then tell the man them that you don't wanna speak to me. Chippy, don't run, don't run. If you lead now, it won't be no fun, no fun.